Okay, today we're going to be continuing our unit on complex numbers with notes for 13.2. So let's talk about complex numbers for just a second. So it's considered a number 5 plus 2i. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This type of expression is called a complex number. We talked about this last time, and we also talked about the standard form of complex number last time, but we'll say it again. Standard form for a complex number is a plus b. Okay, and that's important because Delta Math and other programs will not accept your answer unless it's written in the standard form. They want your real part followed by your imaginary part. Okay? So the goal of today is to add, subtract, multiply, and divide imaginary numbers. Okay? Adding and subtracting is pretty easy because all we have to do is combine like terms. Okay, so looking at example 1, my real parts of both of these are -11 and 9. And my imaginary parts are 3i and 2i. So I'm just going to combine like terms. I've got -11 plus 9, which is going to give me -2. And then 3i plus 2i is going to give me 5i. Okay. And that's it. That'd be my final answer there. I just combine like terms. Now in example 2, it's very similar to the first one, but now we're subtracting. Okay. When we're subtracting two of these numbers, we can't just combine like terms. We have to first distribute this negative to that second set of parentheses. So I'm going to rewrite this. The first one's going to stay the same, and the second is going to become a -2 minus 6i. Okay, so I just distributed that negative to both of these terms. And now I can combine like terms. So the real parts, I have 7 and -2. And the imaginary parts, I have -2i and -6i. So that's going to be 5, because 7 minus 2 is 5. And then -2i minus 6i is going to leave me with a -8i. And that would be my final answer there. Okay, so adding and subtracting is combining like terms. But when we have a subtraction, just make sure we distribute that negative. Okay, now multiplying complex numbers. Multiplying isn't like adding and subtracting because we don't have to keep the real and the imaginary separate. We just distribute like normally, whether that number is real or imaginary. So what I mean by this is I'm going to distribute this 2i. I'm going to distribute to 8, and I'm going to distribute to -3i. Doesn't matter that the 8's real, I just distribute it. So I have 2i times 8, which is going to be 16i, and then 2i times -3i, which is going to give me -6i squared. Okay, now I know that I squared is -1, so I can rewrite this as 16i minus 6 times -1, right? Or in other words, I'd get 16i plus 6. But this isn't written in standard form, so I'm just going to rewrite this in standard form. So 6 plus 16i. And that would be my answer. Okay, now in example 6, we're just going to multiply like we normally would, which when we have two parentheses with operations like this, we have to FOIL. Okay, so I'm going to end up with 7 times 4, which is 28. 7 times -i, which is -7i. I times 4, which is 4i. And I times -i, which is -i squared. I'm going to combine like terms. So I've got 28 and then -7i plus 4i, is negative 3i. And then I've got a negative I squared. That I squared is going to become a negative 1. Okay. So in other words, I've got 28 minus negative 1, or 28 plus 1, which means I'm going to end up with a 29, and I'll still have that 3i. And that would be my final answer there. Okay, now in example 7, we again have to FOIL here because we've got an operation in the middle of this, so you can't just distribute that 2 to each, you have to FOIL. Okay, so I've got 6 times 6, which is 36, 6 times negative 2i, which is negative 12i, negative 2i times 6, which again is negative 12i, and then negative 2i times negative 2i is positive 4i squared. Okay, I'll combine like terms and replace this I squared with a negative 1. So I'll end up with 36 minus 24i minus 4, because 4 times negative 1 is negative 4. Okay, and now my last step is 36 minus 4. Those are like terms. So I'll end up with 32 minus 24i. Hmm. In example 8, I'll distribute or FOIL just like I normally would. So 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. And negative 3i times 3i is negative 9i squared. Now, this 6i and negative 6i are going to cancel each other out. And so I'm going to end up with 4 plus, minus 9 times negative 1, which is just 4 plus 9, which will result in 13. Okay. Now, if you look at the original question here, it says 2 minus 3i times 2 plus 3i. The only difference between these two is one's a minus and one's a plus. So if I was referring to the first set of parentheses here, 2 minus 3i, I would call this second set the conjugate of this first set. And what the conjugate means is it's the exact same thing, but it just flips the operation. So it was a subtract, now it's a plus. The reason we want conjugates is because it's going to help us in division when we're dividing these. And the nice thing about them is every time we multiply by the conjugate, these middle terms are going to cancel out, and this is always going to end up as an I squared or a negative 1. So we're always going to end up with a real number when we multiply a number by its conjugate. Okay? So that'll make a little more sense as we do some examples. But when dividing complex numbers, there's 2 methods, okay? If the denominator is a monomial, meaning it's only got one term, like example 9 and example 10 only have one term in it, then we're going to multiply the top and bottom by I. But if the denominator is a binomial, like example 11 and 12, that's when we're going to multiply the top and bottom by the conjugate. Okay, so let's do some examples here. On number 9, it is a monomial in the denominator, so I'm going to multiply both top and bottom by I. So 10 times I is 10i, and 2i times I is 2i squared. So if I plug in my -1 instead of this I squared, I get 10i over -2. And then because both of these are divisible by 2, I can simplify this to -5i. And that would be my final answer. Okay, the reason I'm doing this, I'm multiplying the monomial ones by I on top and bottom, and the binomials by the conjugate, is because just like a square root, we never want a square root on the bottom. We always want it on the top. That's why we rationalize our fractions. We never want an imaginary number on the bottom of our fraction. So when we do this, we end up with no imaginary number on the bottom. That's why we're doing this process, because imaginary numbers don't belong on the bottom of fractions, only the top. Okay? So in example 10, I've got a monomial on the bottom. I've only got one term. So I'm going to multiply top and bottom by I. Okay? Now the important thing to remember here is that this I has to go to both of these terms. It's got to distribute in. Okay? So I'm going to end up with 8 times -8 times I. Sorry, said that wrong. So I've got -8i, and then -2i times I, which is -2i squared. Then on the bottom, I've got 6i times I, which is 6i squared. Now I'll replace these I squareds with -1s. So I'll still have a -8i, but instead of a -2i squared, it's going to become a +2. And on the bottom, I'll have a -6. Right? 6 times -1. Okay. Now, all of these can be divided by 2. So I'll do that. I'll end up with a -4i plus 1 over 3. And then my last step is to make sure the top is written in standard form. So I'm just going to say 1 minus 4i over 3. Now that's written in standard form. I have no I in the denominator, so I'm good to go. Okay, so on example 11, this is where the conjugate's going to come into play, okay? So I'm going to multiply both top and bottom by the conjugate. Remember, the conjugate is the exact same thing, but I flipped the operation. So it was a negative, now it's a plus. It was a subtract, now it's a plus. And I'll multiply that on top and bottom. Okay, so I've got -2 times 5, which is -10, and -2 times I, which is -2i. And then on the bottom, I'll have 5 times 5, which is 25, 5 times I, which is 5i, -I times 5, which is -5i, and -I times I, which is -I squared. Okay, just like in example 8, because I'm multiplying by the conjugate, those middle terms are going to cancel out. So what I want to happen. Okay, now if I simplify this, I'm going to have -10 minus 2i on top still. And then I'll have 25 minus, so it's minus I squared. I squared is -1, which means I have -10 minus 2i over 26. 25 minus -1 is 26. And now my last step, all of these are divisible by 2. So I'll have a -5 minus I over 13. Okay, so I have no I on the bottom, which is what I was looking for. Okay, example 12. I'm going to multiply both top and bottom by the conjugate, which is 2 minus I. It was a plus before, now it's a minus. So I'll do that on top and bottom. So I've got 7 times 2, which is 14. 7 times negative I, which is negative 7I. 3I times 2, which is 6I. And 3I times negative I, which is negative 3I squared. And on the bottom, I've got 2 times 2, which is 4. 2 times negative I, which is negative 2I. I times 2, which is positive 2I. And I times negative I, which is negative I squared. Now I will combine like terms and plug in negative 1 wherever there's an I squared. So I'll end up with 14. And then negative 7I plus 6I is negative I. And then negative 3 times negative 1 is positive 3. And on the bottom, I have 4. And then this negative 2I and positive 2I will cancel each other. And then a negative 1. So negative 1. Or subtract negative 1. Okay. Now I can combine my 14 and my 3 to make 17 minus I on the top. And then 4 subtract negative 1 is really 4 plus 1, which is 5. And that will be my final answer for example 12. Okay, so that's the end of notes today. On this next page, we will do 2, 7, 12, and 16. Once you get those ones complete, that practice, there is a Delta Math online. And that's it for today. Thanks.